Alrighty, welcome to 2.4. We're really going to start getting into some of our proof stuff. Before we actually get into writing the proofs, we want to get through some of the vocabulary, some of those basic axioms, postulates, and stuff like that. And so we're going to start 2.4 day uno. We're gonna break this section up into 3 videos. This first one's gonna be a little bit short, and I think you'll won't have a problem with that. So I'm gonna go ahead and zoom out. I'm gonna let you write down all these, and then we'll chat about them really, really quickly. So hit pause, and then we'll go. Welcome back. It's been so long. So a postulate is something that doesn't have to be proven true because it's considered to be common sense. Okay? It's going to be a little bit different from what's going to be called a theorem. A theorem is something that we didn't know, but we've proved it so often that now we say, ladies and gentlemen, that it is indeed true. Alrighty. Now, when you do this, ladies and gentlemen, I'm not going to lie, this is stuff that you can just shorthand. You don't have to remember postulate 2.1. You could say 2 points make a line. 2 points make a line. So it doesn't have to be perfect. You don't have to remember 2.1 because to be completely honest, 2.1 in another textbook could be something completely different. It is just the textbook's reason. So if I were to make a diagram, I would say, all right, let's take 2 points. Let's change up my colors here. We'll call it P and we'll call it Q. So those are my 2 points, and those are going to make line M. Takes 2 points to make exactly one line. Yay! The next one. 3 non-collinear, and the non-collinear part is important, points makes a plane. So again, you don't have to remember the postulate number, just remember the shorthand. Okay? So if we have any 3 points, so A, B, C. So those are not on the same line, so they can make exactly one plane. Cool. Alrighty, next one. At line complete at least 2 points. Now, why are these two different? Well, let's go ahead and make a line. So if I have, ladies and gentlemen, A and B, those are 2 points on that line, right? Now, ladies and gents, are there a lot of other points on that line? Absolutely. I could go C, I could go D, it could go on forever. And I could say that this is line, we'll say line L. So the big difference is that this is exactly 2 points that make one line. This script is saying there could be more. So there's more points on a line. That's the fancy way of saying that one. Because they sound very similar, I'll give you that. Alrighty. 3 non-collinear points, that is what we usually think of when we think of a plane. So this is when we do our corner points, A, B, C, and D. So you could have more than 3. Because it looks like 2.2 and 2.4 are very similar. Alrighty. Then, ladies and gents, we have 2.5. So 2.5 is if we get our line on there, we make our plane. Okay. Now, the big kicker is if we have A and B, if they're on that plane, they're on that line, then that whole line is on the plane. Okay. So it's not just the 2 points that are on the plane. Every point on that line is also on that plane. And you're like, yeah, that kind of makes sense because if this is C and this is D, then those should be on the plane too. They don't get to hover above it. Okay. Alrighty, 2 lines intersect at a point. We'll call that C, and this is A and B. And then this one's a little bit tougher to draw. I think the easiest way to draw it is to get all 3D with it. So that's what I'm going to do here. Helps if I'm drawing things correctly there. So this is my 3D plane here. Cool. So if this is a plane right here, this front, and this side one is a plane here on the side, they're going to intersect at the only part, which is this line right here. Now, you could draw it a couple of different ways. The textbook draws it a little bit differently. But that's the one that makes the most sense to me because that's the one I can draw. The other one, I'm trying to draw two planes that intersect, crossing, kind of like how 2.6 does. Not so much. So again, 2.6 is two lines intersect at a point. And two planes intersect at a line. So again, we don't have to use their postulate numbers. We can sort of just summarize them, call it good. Technically, you should write them in if-then statements, like was the whole reason with doing conditional statements. But we're not so big nitpickers on that. Alrighty, so now let's go ahead and take a look at this. So it says P and Q intersect at R. Okay, so plane P, which is this part right here, intersects plane Q, which is this one right here, at line R. So is that true? Yes, it is true. And the reason is that two planes intersect at a line. Now, it is very possible for two planes not to intersect, okay? But they're going to intersect. If they're going to intersect, it's going to be at a line. Please, again, do not put postulate 2.7 because no one's going to understand what you mean unless you wrote the textbook. And since neither of us have written the textbook, we're going to call it good. Alrighty. So, ladies and gentlemen, it says that F, A, F, and D are on plane P. So plane P are this one right here. So A, F, and D. We can see it on the side there. So again, that is also true. And again, if I put postulate 2.1, sorry, 2. See, I don't even remember. That's not going to work. So I'm going to say any three non-collinear points make one plane. And I say three non-collinear points because they're giving me three. All right, sometimes always true, everyone's favorite game. So always true, 100% of the time. Never true, 0% of the time. Sometimes in between. So, ladies and gentlemen, I always start with always, and then I look for what's called a counterexample. If we can find a counterexample, that means it goes to sometimes. If I cannot find a time where it never works, then that's never. All right. The intersection of three planes is a line. So that is sometimes. It's tough to really show on a video, okay, without having you in person. But if I have one plane going this way, one plane going this way, and then another plane going this way, well, those intersect at a point, or they could intersect at a plane, okay? So I'm going to go with sometimes. But, because if we think about it as like a box, let me see if I can make a box here. So here's my box. Here's one plane, another plane, and they intersect here. I could have this one coming out this way, out from the screen. So I'll just put a line down saying it's coming out from the screen. That'd be one time. It's tough to do. Tough to do when you're not in front of me, but we'll do what we can. Through 2 points, there's exactly one line. That is always. We know that's always true because 2 points make one line. And last but not least, it says that N and K are collinear. So N and K. Those don't look like they're part of the same line. But this is actually always true. And the reason why it's always true is that I can make a line through any 2 points. Alrighty. Ladies and gentlemen, don't overthink this. Find a counterexample if you can, sometimes. Can't, always. Remember these definitions. But remember them in more general terms of 2 points make a line. Don't remember them as postulate 2.1. You guys have a great day. We'll see you next time when we start jumping into algebra.